Hello, everyone. Welcome back. In this video, we will use a couple of examples to demonstrate and how to determine the complexity of the algorithm using big O notation. So let's first look at this, this example here. So we're going to look at this simple example, and this is the loop, and here is for I in range n, and we're going to perform this statement for each I in this range, and we're going to perform this statement. Now, and what is the time complexity? So here, this addition and then assignment, this is total, and that is the constant time. And how many times we're going to do this? And that's the n times. So you put this all together, that's the time complexity. Here's a constant time times n. Since we can ignore the constant factor using big O notation, so the final and simple notation for this complexity, it's out of n. So that's a simple loop and the linear time. And we can actually run the code and see and how it behaves when you actually execute it. So when you actually execute the code, so let's write a test program as this. So we're going to have this, the main, we're going to test this with the size, the input size is 10,000 and 100,000 and 1 million and 10 million. So here is the loop, and we're going to get the time. So we get the time, this is the time, the start time, this is the end time. So we're going to get, after this execution of the loop, we get the end time. Now you can see that the end time, it is about 10 times more. You have the input size is 10 times more than the previous one, and the time is, so roughly is 10 times more. So this is roughly the 10 times more than the previous one. And this is the, now you need to get the really large number and to see the time complexity when you test it. If your input size is too small and you don't really see much the difference. All right, so let's get another one. Here is the second one is this nested loop. All right, so we're gonna have this, it's I is in range, this range, and J is in this range in. So, and we're gonna execute this for every J and in this range. So we're gonna perform this. All right, so this is the constant time. And here, and this is in the loop, that is n times. And then for each outer loop, you're going to one time of this inner loop. So the total complexity, it's this the constant times n, and this it's out of n squared time. So the complexity for this nested for loop is out of n squared time. And let's look at another one here. Is this is the I is in this range, and here we have this is J, so this should be written as J. Okay, so this is the J. All right, J is in this range. All right. So what is this time complexity? So this one here is a constant time plus assignment. And now how many times this J is done? So it depends on I. So when I is 0, there's nothing. I is 1, you do 1 time. So then 2 times for this I is 2, and then 3 times for I is 3. And this is the last one, and this is the total complexity is you're gonna add all this together. So this 1 time, 2 times, 3 times, n time. So this together, it is out of n squared time. So because you're gonna ignore the non-dominating part. So this is the n part is non-dominating part. You can only retain the n square part, and you ignore the constant factor. So this eventually it is order of n squared time. So the complexity of this is the same as the previous one. So the previous one, this is the previous one. So the previous one is this, okay? And this is the one, it's the n squared time, and this is also n squared time. All right, let's look at one more here. And for this nested for loop, so now look at this I, this should be J. All right, so this one here, and I is in this range, and J is here, and range is 20. So what is this? And this is constant time, and this is 20 times this constant time. And the overall complexity, it's n times this 20 n time a constant time. And the complexity is order of n, so this is linear time. So it doesn't matter whether it's 20 or 20,000, as long as it's a constant, it can be ignored, because we assume this n is very, very, very large, goes to infinity. All right, so let's look at another example. It's a sequence. So you have this for loop, and then you have another for loop right here. So for this, the first one, you have this 9 times, and nine time a constant time. And then this, it's I is in this range, n, and this is the, and this one here is J in this fixed size. All right, so what is total? And total is this. This is 10 times here, so C times 10. And here is 20 times C and times N. So the complexity is order of N. Now let's look at a selection here. For this, list that contains. Okay, now this one here, we are using a different one here. So we need to look at the code in Python. Is here is the element in the list. So we're going to print. So we're going to print this. Okay. All right. So we print this else. We look at this is for every element. Okay. In the list. Okay. So I'm going to use the one from the book for this. So let's go back to the book. So let's go scroll down, just make sure I have it correct. So this look, J is correct. And this one going. So here, this is the correct one. So if E in the list, all right, so, and this, the time for this, it's order of n time. Else, and this, it's order of n time for this loop. So the overall time, it's this order of n time. All right, let's look at another example is this. We're gonna write the code to get to the computer as n. So the a is the power raised to n. and for integer n. A simple algorithm would multiply this a n times like this. So the complexity is order of n. Now you can rewrite the code and using this. We're going to assume that for simplicity, we're going to assume that n is it's an integer, and which is 2's power raised to k for some k. So like n is 4, it's 8, it's 16. So this kind of numbers, n is this. So we can get the result by doing this. Result is initially is a, and now we're going to do it only k times and multiply the result. Result time result, and now continue result time result, and that is more efficient way to do it. And this will give you order of k time, and k is order of log n. So that is the time. All right, so that is all for this section on the examples of determining the big O notation for the algorithms. See you on the next video.